see a couple of general ideas of the logic. I'll go and write just a moment. Okay, for example, the small topics of the logics we'll study is the statement. Okay, we'll study negations. Okay, the word negation basically means отрицание. I'll write it. Okay, we'll study ends or connectors. Okay, the most important thing of today's lesson, we'll study DeMorgan's law. Okay, basically that's the plan for today. And in the following lessons, we'll study also the if conditions. So I really encourage you to take notes because you can check, when our lesson finishes, you can check, you can do some small research. You can watch some videos on YouTube on those topics, and so it will be helpful for you. So that's the if conditions. Give me a moment. Okay, also we'll study necessary and sufficient conditions. Okay, this is a really important topic because you'll have a lot of exercises on necessary and sufficient conditions. And also, we'll study all, at least, statements. Yeah, I know it may appear you something new, but it's not really hard. And also, we'll go and study the truth. It's kind of a game, who tells the truth and who tells the lies. For example, I'll write truth and false statements. And basically, the rest of the course will be on solving the exercises. Basically, those exercises are from official tests. And some of those exercises, exactly those exercises, you can have on your official exam. So I really recommend you to do all homeworks. And yeah, we can go for today's lesson. Okay, the first thing we are going to study is the statement right here. Okay, what do you think? What means statement? How would you describe it?
It's like arguments, how I understand from the video.
Yeah, it's kind of an argument. Let's say it's kind of a sentence. Just wait a second. All right, sentence. So basically, this is the statement. This is a statement. This is a sentence that can be either true or it can be false. Yeah. So basically, you have two phases of the statement. It can be either true or false. For example, I'll write you a statement. Let's say the Earth is round. Okay, let's say this is our statement. And usually what we do in logic, we kind of denote the statement. I'll write our statement, the Earth is round. This is the same as A. Let's imagine this whole sentence we denote as A. And A, this is our statement. And let's imagine we are, let's say, 2,000 years ago, right? And 2,000 years ago, people didn't know that the Earth is round. So that would be a kind of a statement that could be either true or that could be either false, right? So let's imagine this is our statement, the Earth is round, and this can be either true or can be either false. Just give me a small moment. I'll give you a picture from the previous lesson, if I have it. Yeah, here it is. Okay, let's imagine we didn't know if the Earth was round or not. So because some people thought that the Earth is flat and it's holding on 3 elephants, which are on the giant turtle, as you see here. And basically A, this is our statement. And let's suppose that A is true. Let me write it here, that the A is true. All right, now we are going to have another point. I'll write it here. Another point, this is the negation. So negation, basically, we denote by this sign. I'll write like this one. So anytime you see this sign, you need to know that this is the negation. And basically, this is just the word not. So the sign means the word not. Okay, if you know that our A is true, right? We know that our A is true. We know that the Earth is round. What if I tell you, what's the value, what's the validity of not A? What do you think? If the A was true, what's the validity of not A?
False.
Yeah, it will be false. Because, okay, let's imagine it like this. You had A and you had true. So basically you negate both sides and you'll have not A equals not true. And you know that not true. So this is the same as false, right? Because true and false, these are the binary words. For example, you can have man and woman. These are also binary words. For example, if you have true and you write not true, so not true means false, right? And the same stuff, if you have false and you write not false means true. For example, if you have man and we write not a man, so not a man means woman, right? And if you have woman, you write not a woman means man, because those are the binary words. It can be either 1 or 2. There is no other options. Okay, if you have not a, will be false. Okay, now let's imagine we have this scenario. If I write to you, what's the validity of not a, what would you answer me?
True.
Yeah, not a will be true because you had that. You have not a, this is false. I'll write it here. Not a, we know that this is false, right? This is false. And what we have now, we have not false, and not false, this is the same as true. So you just need to remember that anytime you have double negation, I'll write double negation. So anytime you have double negation, those two signs, this not, they will cancel out, and you'll remain with a. And let's try to negate our statement. I'll go back here, and I'll just write again. Statement was, the earth is round. Okay, if this is our a, okay, what will be not a? How you can contribute not? So if our statement a is the earth is round, what will be not a? How can you contribute the not?
The earth is plate, like.
Okay, you can write the earth is flat, but you can write also the earth is not round. Okay, basically you need to contribute this not into our statement. So you'll have the earth is not round, right? And not round, you can then replace as a board flat, but we don't do it for now. And what if I tell you, how can you contribute another not? What will be not a? So if you know that our a is the earth is not round, how can you contribute the second negation? What do you think?
The earth is round.
The earth is round, true. Yeah, because two negations will cancel out, but before, to cancel them out, how can you contribute second not? Will you write the earth is not round, or you have different option? What do you think?
The earth is not flat.
False, that the earth is not round.
Yeah, that's correct. Good. Apply. We'll write at the beginning, we'll write just the word. It is false that. And we rewrite the statement, right? So basically the first not will be contributing into the statement as this word. It is false that. Okay, then we write this other stuff will be the earth is not round. And if you think logically, the statement it is false that the earth is not round, then the statement will be the earth is round, right? So basically what you'll have here, this not and this not will cancel out, and you'll remain with the original statement, the earth is round. Okay, do you have any questions here? So far, so good. Okay, then we can continue on. Just give me a moment. Okay, now we'll talk about and. This is our third point. We'll talk about and we'll talk about or. So these are two connectors, and or. And basically what you do is those connectors, you build complex statement. For example, if you had the statement A, and if you had the statement B, using and using or, you can build from those two statements, you can build a more of a complex statement. For example, you can build A and B, or you can build A or B. And now you need to see the difference. What's the difference between A and B, and what's the difference between A or B? Okay, in the case of an and, so A and B, the whole statement will be true. I'll write will be true only if left side is true. I'll write left side is true and right side is true. For example, here you have A and B, and in our case, A is the left side and B is the right side. So A and B, the whole statement A and B, it will be true only if in one case, when A is true and B is true. In all other cases, it will be false. But what about A or B? If you write A or B, the whole statement A or B will be true when we have at least one of the sides is true. Okay, our whole statement A or B will be true for us enough that we have only one truth. So it's either A true or B true, or they can be both true. In these three cases, our statement A or B will be true. And let's try to think about it. We'll build a truth table. I'll go back here. Okay, let's imagine that's our A, that's our B, and here we'll have A and B. And we can have 4 possible ways. For example, the first way where A is true and B is true. Okay, what will be the truth validity of A and B in this case?
True.
Yeah, it will be true because from here you have that will be true only if left side is true and right side is true. So in our case, left side A is true and the right side B is true. So the whole statement will be true. What about if A is true but B is false? What will be the truth validity?
It will be false.
Yeah, it will be false because we have that the right side is not true, it's false. So another case where the A is false and B is true, what will be the truth validity of A and B?
False.
Again, false. If we have both false, what we'll have here?
False.
Yeah, so just remember, A and B will be true only in one case, where A is true and B is true. So this is the first case and the only case. But what if I build you another table? Just give me a moment. Okay, you have again A, you have again B, you have A or B in this case. And you can have 4 possible ways of rearranging truths. For example, the first case, A is true and B is true. What will be the A or B? Will it be true or false?
False.
Not really, because
True.
you see here, A or B will be true when we have at least one of the sides is true. Okay, the word at least means 1 plus. So if you have A is true, I'll write true, and B is true, I'll write true. This satisfies this condition. This satisfies at least 1, because we already have 1. We can have 2 truths, we can have 3 truths, and so on. But the word at least means 1 plus. So in this case, A or B will be true. But what about if A is true but B is false? What we'll have here?
False.
Not really. Think about it. It's written when we have at least one of the sides is true. Do we have at least one of the sides is true here?
Yeah.
Yeah, then it will be true, right?
Yeah.
I'll write it true. Okay, what about if B is false? No, if A is false and B is true, what you'll
It's
have?
been true.
It will be true again. In the last case where the both sides are false, what you'll have in this side? In this
It's
case.
false. Yeah.
So just remember that the A and B can be true only in one case, and A or B can be true in 3 cases. 1, 2, 3. So A or B is false only if where the left side and the right side are falses. So that's the difference between A and B and A or B. And basically, you can imagine this as a statement. Let's give you an example. For example, if I write the statement, I will go to the cinema, and let's say we write if condition. If, let's say, need to come up with 2 names. Let's say if John goes, or let's say Jenny goes. So here what you have, I will go to the cinema. If John goes or Jenny goes, basically you can denote John goes as A, you can denote it as A, and Jenny goes, you can denote it as B. So you'll have, I'll go to the cinema if A or B. And let's say the first case, let's imagine I'm asking to you, will I go to the cinema if John goes to the cinema, but Jenny will not go? Will I go in this case?
Yeah, we will go.
Yeah,
because Johnny is goes.
Yeah, true. The first case, when A is true, but B is false, I will still go to the cinema. I'll go. Okay, what about the second case? Let's say, will I go to the cinema if John will not go, but Jenny will go? Let's say A is false and B is true. In this case, will I go to the cinema?
Yeah.
Sure, I will go. And the third case, that's the case where A is true and B is true. So basically, it means that the John is going to the cinema and Jenny is going to the cinema. In this case, for sure, I will go to the cinema. In the last case, this is the only case where I will not go to the cinema, where A is false and B is false. So only in this case, it means that will I go to the cinema if John will not go and Jenny will not go? In this case, I will not go, because in order for me to go to the cinema, I need to have at least one of the friends that are going to the cinema. But in this case, they both are not going. So I'll write I not go. And you can come up with the same stuff with A and B. So basically, you can build the statements. I'll go to the cinema if John goes and Jenny goes. In this case, I will go to the cinema only when two of my friends will go to the cinema. Okay, so far, do you have any questions about A and B and A or B, about those connectors? So far, so good?
Yeah.
Okay, we'll go next. Okay, the next part, all of this stuff you're studying in order to understand one thing. So the most important part of the lesson is to understand DeMorgan's law. So basically, DeMorgan's law states that if you have, I'll write with blue, if you have not A and B, so in this case, you need to kind of imagine this not sign as a multiplication, and you need to contribute this not into the brackets. So it's kind of a math, you know, you are contributing multiplication to the A, to the B, and also you contribute not to the end. And basically, DeMorgan's law states that not A and B, this is the same as not A. So basically, you contribute not to A, and you'll have not A. You contribute not to B, you'll have not B. And you contribute not to the end, and you'll have or. So and becomes or. And this is the statement, this is the law. If you have not A and B, this is the same as not A or B. And we can try to build it in another way. You can write, if you have not A, let's say, or B. So in this case, again, you have to imagine this sign not as a multiplication, and you need to contribute this multiplication into the brackets. So how do you do it, right? You contribute it to the A, you contribute it to the B, and you also contribute it to the or. And what you'll have here, you'll have not A and not B. So basically, just try to imagine that not and equals to or, and not or equals to and. So basically, this is the DeMorgan's law, and you need to kind of see in the questions, you kind of need to use it. And yeah, we'll use it later a little bit, but first we kind of, if you're still in doubt, if you still don't believe me that not A and B not equal to not A or B, we can check it using the truth table. Okay, I'll be the truth table. Just give me a moment. I need to have. Okay, you should have A, you should have B, you should have A and B, you should have not A and B, you should have not A, then you should have not B, and the last part is to have a space. Basically, you have not A or not B. Okay, almost done. And let's put the truth values. For example, let's say our first case will be the A is true and B is true. Okay, in this case, A and B will be true, right? Will be true. Okay, what's the value of not A and B? If our
False.
A and B is true.
It's true. It's true. It's
No,
true.
no.
No, it's been false and false.
False.
Yeah,
Yeah, it will be false, because if A and B is true, not true will be false. Okay, what's the value of not A?
False.
False.
Yeah, because our A is true, not A will be false. What about not B?
False.
Yeah. What about not A or not B?
True.
Not really. In order to be true, you have to have at least one true. But here you have
It's false.
and yeah, it will be false. All right, that was our first column. And here you already need to see that I'll just denote that this column equals to this column, right? You have not A and B, which is false. and this is the same as not A or not B. Okay, but this does not tell anything. Let's go for a second column. Let's imagine that A is true, but B is false. What will be A and B in this case?
False.
Yeah, it will be false. What about not A and B?
True.
It will be true. So it's kind of opposite. What about not A?
False.
Right, and
True.
not B in this case will be true. Okay, what's the value of not A or not B?
True.
Yeah, because we have at least one true. In this case, we have B, which is true. Okay, now just take a note that this column equals to this column by truth validity, right? So not A and B is true, and not A or not B is also true. Okay, what about other case? Let's imagine that A is false and B is true. What will be A and B in this case?
True. Wait, false, false.
Yeah, it will be false. What about not A and B?
True.
True. Yeah, it's kind of opposite. If this was false, then it's true. What about not A?
True.
Yeah, because the A was false. Not A is true. What about not B?
False.
Yes. And what about not A or not B?
True.
Yeah. Again, just take a look that the column of not A and B, in this case, it's true. And this is the same as not A or not B. And let's check if the last one will be the same or not. The last one will be false. False. What's the validity of A and B?
Oh, false, yeah.
Yeah, sure. What's the validity of not A and B?
False. That's true, it's been true.
Yeah, because it was false. Here you just have the opposite. You have true. What about not A?
True.
It is true. What about not B?
True.
Yeah. And what about not A or not B?
True.
Right. So the last case is also equal, right? So basically, from this, you can infer, we kind of a proof that not A and B has the same truth validity as not A or not B. So it means that they are both equal. So anytime you have something like this, you have not A or not B, you can replace it to not A and B. Or in the other case, if you have not A and B, you can replace it to not A or not B. And it will be really helpful in our case when we will solve exercises. Okay, for you, the first homework will be to build a truth table for the second law. Okay, that was the first case where not A and B equals to not A or B. Okay, the second law is that not A or B equals to not A and B. So try to build such kind of a table and try to check truth validity and try to prove it. That's the first homework. And so far, we've done the DeMorgan's law. Basically, this is two laws, and you kind of need to know them. Okay, here you have statement, all Italians like soccer or basketball is false. It is follows necessary that, okay, anytime you have the, let's say, you have logical exercises, first thing you need to find the statement. And in our case, the statement is all Italians like soccer or basketball. Okay, now after the statement, you'll have some information, right? In this case, it's written is false. And anytime you see the statement and after this is written is false, or you'll have that you will have the word contradicts the statement, or you have to prove this wrong, it means that you have to negate the statement, right? So if you have the statement A and it says that is false, what you need to find, what they want us to find, they want us to find not A. Okay, and let's imagine this is our statement, all Italians like soccer or basketball, this is our A, right? And before to solve this, I need to mention one thing about all statements, right? Okay, the point is that anytime you have all statements, for example, let's come up with a statement, all cats live on Mars. Okay, let's imagine this is our statement, all cats live on Mars, and let's say it's written is false. So it means that you have to find negation of the statement. And if you had all cats live on Mars, this is your A, you need to find not A. Okay, what will be the not A of all cats live on Mars? Okay, in order to find not A, you need to work with all. So basically, what you have here, you have to contribute this not into the statement, right? So in order to contribute it into the statement, you have to contribute not to all, because anytime you have all statements, it means that you have to negate it, right? Let's say you have all cats live on Mars. In order to negate all, you'll have not all cats live on Mars. Okay, this statement, not all cats live on Mars, basically you can leave it like that, but usually you will not find the answers in the answers sections, you will not find not all. So basically you have to work further. Not all, this is the same as at least one or some. For example, what you can do here, you can write, instead of not all, you can write at least one cat doesn't live on Mars. So basically, this is the full equivalent statement of the statement, not all cats live on Mars. This is the same as at least one cat doesn't live on Mars. For example, let's imagine my statement is all cats live on Mars. For example, I come to you and say to you, hey guys, I know the truth. My truth is that all cats live on Mars. And for example, Aiganish comes to me and says, no, Exudan, you are wrong, because in Aiganish, you need to, tell the contradictory statement. And your contradictory statement is to find at least one cat which does not live on Mars, right? If you find to me at least one cat which does not live on Mars, then you can totally contradict my statement. My statement was that all cats on the universe, they live on Mars. And in order to contradict it, for you, it's enough to find at least one cat which does not live on Mars. And yeah, at least one cat doesn't live on Mars. And this is the full equivalent statement. So not all cats live on Mars. Okay. The second way to negate not all, you can write some. You can write some cats doesn't. Let me write don't live on Mars. So basically, the word some means from 1% until 50%. So basically, some cats, it can be one cat, it can be two cats, it can be 10 cats. The word some means the from 1% until 50% of the total amount of cats. And yeah, if you have the statement, not all cats live on Mars, you can either go to way of negating to through at least. You can write at least one cat doesn't live on Mars, or you can replace it with some. You can write some cats don't live on Mars. And if we go back here, let us denote the statement as all, let's say, P. Instead of cats, I'll write P. I write all P are, let's say, Q. And this is our statement. All P are Q. And in order to negate it, I write, in order to contribute not into the statement, you'll have two ways. The first way is at least one P. At least one P is not Q. This is the first way. The second way, you can write some P are not Q. So in this case, P is our cats, all P is all cats, and Q is the statement live on Mars. So basically all P are Q means that all cats live on Mars. And in order to negate it, you write at least one P is not Q, or you write some P are not Q. And we do the same stuff here. For example, what you have here is all Italians like soccer or like basketball, right? Right, all Italians like, what was it? It was soccer. And it was or like basketball. Okay, now let's denote the word like soccer. Let's say this is our A. And let's denote like basketball. This will be our B, right? And the new statement, you'll have all, let me write, instead of Italians, let me write just the word I. Okay, all I are A or B. So basically, this is your statement. All I are A or B. This is the same as all Italians like soccer or like basketball. And what you need to do here, you need to contribute not. We'll contribute not into the statement. And you can go to two ways. Okay, the first way, you can write at least one Italian. I write at least one I is not A or B. So basically, instead of not, let me use the sign in order to apply DeMorgan's law. Okay, this is the first way. The second way, what you can do here, you can write some I, as Italians, I write some I are not A or B. Okay, now what you need to do here, you need to choose between at least one and between some, and you go for the possible answers, and you see the word some, and most probably you'll go for some. Okay, if you go for some, you'll have some I are not A or B. Here we apply DeMorgan's law, not A, not B, and not or. Okay, guys, tell me, what will be this statement equal to? What is this side equal to? Not A or B?
Not A and not B.
Not A
And
and
not B.
not B. That's correct. And your final statement will be some. Okay, instead of I, I'll again write Italians, some Italians. Okay, this you have not A or not B. We replace it with not A and not B. You'll write not A and not B, but A was like soccer. For example, if our A was like soccer, what is our not A? Not A means doesn't like soccer, right? If A was like soccer, not A means doesn't like soccer. So you have some Italians doesn't like soccer. In our case, this is not A, and I'll rewrite and not B. Okay, what will be our not B? If our B was like basketball, what will be not B?
Don't like basketball.
Yeah, that's correct. All right, doesn't like basketball. And this is our answer, right? Some Italians doesn't like soccer and doesn't like basketball. And let's go for possible answers. And here you'll find that C is correct. Some Italian doesn't like soccer and doesn't like basketball. This is correct answer. All right, C. Okay,